Hello again, grade 8s. In today's lesson, we are going to begin a new unit of study in math dealing with linear relations. And this is going to go back more so to the graphical or like visualization aspect of math that we had previously dealt with in the transformations unit. Although we're going to look at this more so in examining equations we can use to write straight lines, and specifically dealing just with plotting data that can represent a straight line. Learning outcome is to graph and analyze two variable linear relations. Now, before we kind of get started on the new stuff for this unit, we're going to do a little bit of a review of some information that we need from Math 7 in order to properly be able to do what this learning outcome identifies, graph and analyze two variable linear relations. We're going to start off by reviewing a bunch of definitions. So we're going to first of all look at a definition of what an expression in mathematics is. And a mathematical expression is a statement that combines operations, variables, numerical coefficients, and constants. The reason that I bolded variables, numerical coefficients, and constants is because we need to further define what those terms are. But let's give an example of what a mathematical expression would look like. So, for example, we have 3a plus 5 is a mathematical expression. I did just want to point out one thing, though. So if we look at this part of the expression, we have like the 3a part. Now you have this 3 and you have this letter a. Now, even though it doesn't show it, there is an implied operator that does exist between both the 3 and the a. So anytime that you see like a number directly beside a letter, the implied operation is multiplication. So we could actually expand that expression so it looks like 3 times a plus 5. It's just common mathematical convention to not show that multiplication operator. We just write down 3 and the a right beside each other. So let's start off by defining these different terms that make up the definition of an expression. A variable in mathematics is a letter that is used to represent a changing or an unknown quantity. It turns out we've already looked at this. If we go back to, for example, science, we looked at a pressure equation where we had pressure was equal to force divided by area. P, F, and A, those are all variables. The reason they're variables is because depending on the scenario, you could have different values you plug in for F or different values you plug in for A, which would lead to different pressure values. Therefore, these letters are being used to represent values that can change depending on what the scenario is. Or more often in mathematics, if we have a variable, it's typically some kind of like unknown value that we're going to attempt to calculate. So in this example, the variable is pretty obvious. It's just the letter you see here. So A would be the variable in the expression 3a plus 5. And typically a letter of the alphabet or the Greek alphabet, more so in using some variables and some more advanced science courses, are used to represent variables. The numerical coefficient is a number and expression that does not change, so its value is fixed, and it's attached to the variable through multiplication. So if we go back up to our expression at the top, now even though in this expression we initially didn't see a multiplication operator, it is implied there is a multiplication operator between this 3 and the variable a. So what I have here is this 3 is attached to the a through multiplication. And because it's attached to the a through multiplication, we call that the numerical coefficient. Therefore, 3 would be the numerical coefficient in the expression 3a plus 5. We also have a constant term, which is defined as a number in an expression that also does not change, so it has a fixed value, and it's separated from the variable, but this time around through addition instead of multiplication. So let's go back to our expression 3a plus 5. Well, this 5 here is separate from the 3a through addition. So that's what we refer to as the constant term. So the numerical coefficient is attached to the variable through multiplication, the constant term is separated from the variable through addition. Now, a few notes about this. If you have an expression where you don't see a numerical coefficient in front of the variable, the assumption we always make is that it is equal to 1. So let's take the expression b minus 7. Now, if you initially look at this expression, in front of the b, I don't see anything, okay? There's nothing there. Now, your gut instinct might be to tell you, okay, well, if there's nothing there, then there is no numerical coefficient, and therefore the numerical coefficient would be equal to 0. But that's actually incorrect, because if the numerical coefficient was equal to 0, then you'd have a numerical coefficient of 0 multiplied by b would be equal to, well, anything multiplied by b would be equal to 0, therefore you wouldn't see anything there. So the question really is, what could you multiply by b that would just be equal to itself? And the answer to that question is 1. So even though I don't see the numerical coefficient of 1 here, it's just implied mathematically that a 1 is in that location. So in this expression, the numerical coefficient would be equal to 1. 2, a constant term can actually be either a positive or a negative number. It just depends on whether it's separated from the variable through addition or subtraction. So in the expression we had at the top of the page here, where you had like 3a plus 5, there's a positive term that separates the constant from the variable and the numerical coefficient. So in that case, the constant term would be a positive number. But let's say we have this like expression b minus 7. Well, I define a constant as being a number that's separated from the variable through addition. You could actually take this expression and rewrite it as an addition statement as follows. B minus 7 would be the same thing as writing b plus negative 7. So I still have the constant term separated by addition. It just so happens that the constant term itself would then have a negative value. So if you do have the constant separated by subtraction, then the constant term is going to be a negative number. Okay, so the constant term here would be negative 7. Okay, let's go look at a bunch of different expressions in this example and try to identify what the variable numerical coefficient and the constant term would be for all of them. Okay, so the first one I have is the expression negative 7x plus 5. Now, the easiest thing to identify in an expression is hands down the variable, because the variable is just going to be represented by a letter of the alphabet or a letter of the Greek alphabet. So in this case right here, negative 7x plus 5, the variable would be x. The numerical coefficient is a number that is attached to the variable through multiplication. So in this expression here, even though we don't show it, you could write it as negative 7 times x plus 5. So the negative 7 is attached to the variable through multiplication. So my numerical coefficient would be negative 7. The constant term, well, it's separated by addition, so that would just be 5. Okay, this expression is a little more tricky to look at. So first things first, what's the variable? Again, it's the obvious one. It's the letter. So we're going to use z to represent that. Now, what's the numerical coefficient going to be? Well, if we write this out, this would be the same thing as writing 20 minus 2 times z. So in this case, what's attached to the variable through multiplication? It's actually going to be, so I'll kind of highlight this in a different color. Okay, not only is it the 2, it's also the sign in front of the 2. Okay, so here you would have 20 minus 2 times z. So your numerical coefficient would actually be negative 2. Here, what about the constant term? Well, the constant term is what would be the sign in front of the 20? The sign in front of the 20 would just be positive, because you could write this also as being like positive 20 minus 2 times z. Therefore, your constant term would just be 20 in this situation. Okay, how about this one? You have negative 12 minus h. Well, you don't see a numerical coefficient in front of the h. So if you don't see that, we assume it is a 1. Therefore, I could write this as negative 12 minus 1 times h. Okay, so the variable is obvious. That's an h. And then what's the number that's in front, or what's the number attached to the variable through multiplication? It's the 1, but it's also the sign in front of the 1. So here, we can just highlight this again. This would be negative 1. Okay, so your numerical coefficient here would be negative 1. And then what about the constant term? Well, this time around, the constant term has a value of 12, but there's a negative sign in front of it. So the constant term this time would actually be a negative number, and it would be negative 12. Okay, 3 over 5y minus 9. Okay, variable. It's obvious. It's just a y. What's the number that's attached to the variable through multiplication? Well, it's actually this entire fraction, because you could write it as 3 over 5 multiplied by y minus 9. So the entire fraction, 3 over 5, would be the numerical coefficient in this situation. Okay, what's the constant term? Well, the constant term is not only the 9, but the sign in front of the 9. So you'd actually have to include that negative as well. So this would be a constant that's negative 9. Okay, so it's separated through subtraction in this situation. Okay, in the final one, you have negative p plus a quarter. So again, if you don't see a number in front of the variable, it's always assumed to be 1. So if I wanted to, I could write this as negative 1 multiplied by p plus 1 over 4. Okay, so what's the variable? Well, again, that's the obvious one. It's a p. And then what is the numerical coefficient? It's the number attached to the variable through multiplication. So that's the 1, but also the sign in front of it. So that would be the negative 1 there. Okay, so negative 1. And then what's the constant term? So the constant term is separated by addition or subtraction. So the constant term here would just be a quarter. So it would be 1 over 4. Okay, now we're going to take this one step further. Not only are we going to look at an expression, but we're also going to try to find a way to evaluate them. Now, the way you evaluate an expression, and again, we've done this already in science beforehand, where we've actually like subbed numbers in for the variables and done a calculation. That is what it means to evaluate an expression. So to evaluate an expression, you do it by substituting the variable with a given value and then carrying out the order of operations on the expression. Okay, so let's say we have the expression 3a plus 5, or you could write it as 3 times a plus 5 if you want to show that multiplication operator between the numerical coefficient and the variable. And I want to solve this for, or evaluate this when a has a value of 4. So the way to evaluate it is you simply just take the value of a and do a substitution. So I'm going to pull this value of a, and then I'm going to plug it in right here. Okay, I'm going to replace a with a 4. Now, there's actually 2 ways you can show this, okay? One way you can show it is with brackets. So in this expression here, we have 3a plus 5. Usually what we do is when we're doing a substitution in mathematics or in a science course, when we do a substitution, we want to do a substitution by replacing the variable with a number in brackets. Now, anytime you see a number with the brackets around it, like you have 3 bracket 4, that means multiplication, okay? So brackets, we write it in an actual expression and imply that you're going to carry out multiplication. Or you could write it like this. You could say it is 3 times 4 plus 5. Now, to evaluate this, we'd have to follow the correct order of operations. So the question is, do you do 3 times 4 or 4 plus 5? Well, if we use that acronym BEDMAS, that would tell us we want to do the multiplication before the addition. Okay, so you have 3 times 4 plus 5. So this would be 12 plus 5. And if you evaluate that, that would be equal to 17. Okay, so let's evaluate these ones. So it says evaluate each of the following expressions using the given value. Okay, so let's go back to my red pen again. Okay, so what I want to do here is in the place of x, we're going to do a substitution and replace it with that -3. Now, again, it's more common in terms of convention in mathematics just to do a substitution by putting the number in brackets. So what I would do here is I could write down 5, and in the place of x, we're going to write down bracket, because this is the thing we're subbing in, -3, and then we're going to subtract 15. Okay, now, what order of operations do you do first? Well, you could go 5 times -3, or you could go -3 minus 15. Multiplication comes before subtraction. Therefore, this would be equal to 5 times -3 would be -15. And then, so we're gonna, maybe I should clarify this here a bit. Okay, so we're doing this part first. 5 times -3. So that's equal to -15. But I still have to subtract this other -15 at the end. So we still need to minus that 15. And then if you're at -15 and you remove another 15, you would then be down to -30. So when I evaluate this expression for x equals -3, it's equal to -30. Okay, -4x plus 10 when x equals 2. So again, what we're going to do is we're going to take this value of x and replace it with the 2 here. So we'll write down -4. And again, the more common way to show this in mathematics is with the bracket notation. So we do a substitution, we sub it in with brackets. So you have -4, and we're plugging in the 2 plus 10. Oops, sorry about that. I got this like weird, funky line that popped up. Let's see if I can erase it. There we go. -4 times 2 plus 10. All right. Order of operations is going to tell me you have to do the multiplication before the addition. So we're going to take care of this part first. So then this would be equal to -4 times 2 would be -8. And then -8 plus 10. So again, we did -4 times 2, which is -8. And then we have to add 10 at the very end here. So then this would be equal to -8 plus 10 would just be +2. Okay, part C, we have 12 plus 3x when x is equal to -4. Okay, so again, we're going to take the value of x, which is -4, and we're going to do a substitution here. So this would look like 12 plus 3. And in the place of x, we're going to replace the x with the number in brackets. So it'll be -4. And now the order of operations is a little bit different here. So you could either go 12 plus 3 or 3 times -4. But again, the multiplication has to come before the addition. So we're going to take care of that part first. So then this would then be equal to 12. And then plus, what's 3 times -4? It would be -12. And then if you're at 12 and then you add -12, that'd just be the same thing as going 12 minus 12. That would be equal to 0. Okay, this next one, you have x, you have it as a fraction, x fraction 2 minus 7, when x is equal to 16. Now, anytime you see that fraction sign, it means that division is the operation that we're going to complete. So in this case, this would be x divided by 2 minus 7. And I'm going to take 16 and replace the x with it. So this would be 16. Again, you can put it in brackets if you want. 16 divided by 2 minus 7. Now, the order of operations here would tell me you must do division before subtraction. So this is the thing I'm going to do first. Sorry about that. Okay, so we're going to do this first. Okay, 16 divided by 2. And then this would be equal to, 16 divided by 2 is 8, minus 7. And then 8 minus 7 would just be equal to positive 1. Okay, box that answer. Again, 16 divided by 2 gives you the 8 here. And up here, the 3 times the negative 4 actually gave you the negative 12. Okay, final one. I have 20 minus x. Okay, so we're going to take the negative 30 and replace x with it. So this would be 20 subtract negative 30. And that is going to be equal to, okay, now here, when you subtract a negative number, that is identical to adding a positive number. So we're going to change this to add a positive. Therefore, 20 plus positive 30 would just be equal to positive 50. Okay, so that's it for this lesson. And you can practice this lesson by completing the assignment called Evaluating Expressions in the Linear Relations Workbooklet. And I'll talk to you next time.